Hi there and welcome to this video on the history of the atom. Let's start first of all by defining what we mean by the term atom. Well, an atom is the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid and gas is composed of atoms. Atoms are extremely small. Question I'm going to ask here is, exactly how small? Well, let's look at two possible ideas. First of all, here we've got the head of a pin. Now, if you could look really carefully at that head of a pin, you would actually find there are millions and millions, probably billions of atoms would fit onto the head of it. That's amazing. Or we could talk about a spoonful of sugar. Now, a spoonful of sugar would contain this number of atoms. That's a huge number. In fact, it's 602,000 million atoms, which suggests that atoms really are very, very tiny. Got the idea? Let's look at one of our famous scientists not so long ago. The English chemist John Dalton was the first scientist to consider the structure of the atom. And he thought of it this way. He said, all matter is made of atoms. Atoms are indestructible, we can't break them, and they cannot be broken to pieces. Well, if that's so, I think we need to go back even further in time. Now, in order to travel back in time, we need a time machine. Here's the TARDIS. The TARDIS is a time machine that can take us back in time. How far? Yeah, about 400 BC. Now, 400 BC was the time of the ancient Greeks. And this was a very famous Greek philosopher called Democritus. Now, Democritus said, if you take a piece of matter, divide it over and over again, you come to a point where you cannot divide it any further. So if you take something, you chop it, eventually you get to a point where you cannot chop it any further. He came up with the term atomos, which literally means indivisible, and it's from that word we get the term atom. Now, Democritus is a very clever guy because he came up with some ideas about the universe. So his theory of the universe said these things. All matter consists of atoms which are too small to be seen. There's empty space between atoms. Atoms are completely solid. Atoms have no eternal structure, and each atom of a different substance is different in size, weight and shape. Now you've got to realise that Democritus wasn't carrying out scientific experiments. These are like his thought processes. This is what he thought. And it's amazing the depth he went to when we compare it to modern day. In fact, let's go a bit further now into the future. So from 400 BC, let's go to the start of the 19th century. Let's go back to our friend John Dalton. Now, John Dalton, as we've seen before, said this about all matter and atoms cannot be broken to pieces. He also said all atoms of a particular element are identical to each other and different from atoms of other elements. A bit like what Democritus said, isn't it really? But he also said atoms are rearranged in a chemical reaction. So we're starting to get here some ideas 200 years ago about what an atom actually looked like. Let's go a bit further in the future. 1897. 1897 was this very smart guy called J.J. Thomson. And he said, first of all, atoms are not solid spheres. He then said, atoms contain small negatively charged particles called electrons. And most famously, he talked about a plum pudding model. Now he developed this idea that atoms are balls of positive charge with electrons stuck in them, like you've got a pudding with plums stuck in them. Here we've got an idea of it. The purple represents the positively charged pudding and the yellow represents the electrons scattered within the pudding. Let's move forward a bit further. Let's go to 1909. Now in 1909 we had a very famous Cambridge scientist called Ernest Rutherford. Now Ernest Rutherford conducted the famous alpha particle scattering experiments. He explained new evidence as the nuclear model of the atom. He said there was a positively charged nucleus, which is here, surrounded by a cloud of negative electrons, which is here. And what he did, he fired alpha particles at atoms. Now, he found that most of those alpha particles went straight through, which suggested there's a lot of empty space. But some of those alpha particles also got deflected back, and he said that's because they hit the nucleus. So very few got deflected back, which means atoms consist largely of space, but with a very dense middle. The problem with that idea, though, is if you've got these electrons in this cloud, they tended to be attracted towards the nucleus, which is where we we go forward now to 1920, another scientist called Niels Bohr suggested that all electrons were contained in shells, and this is his nuclear model. And for his work he was awarded a Nobel Prize in 1922, a very prestigious award. Further experiments by Bohr and other scientists helped develop what we now know as the nuclear model, and we accept to this day. In the middle you've got a nucleus, around it you've got electrons, and they're found in shells or orbits. So we can now summarise our time chart as this. 400 BC, that's 2,400 years ago, Democritus came up with some great ideas. Now they were developed by these famous scientists Dalton, J.J. Thomson, Ernest Rutherford and Niels Bohr, to eventually we end up with a structure of the atom that we all accept. Thanks for watching and listening, and I'll be back in the video very soon.